Hello everyone, this is Mr. 13 Things, and I'm going to take you now into Google Docs spreadsheet and show you even perhaps a little bit about the share. And we're going to multiply once again this matrix by, let's see, we can do this, by this vector, and hopefully get the answer that we see on this calculator. Once again, I guess the calculator is still there. That vector there. The reason why I'm showing a 4 by 4, that's a typical transformation matrix which allows for a rotation scale. That's being things like shears, reflection, a translation vector here. These typically will generally be values of 0. These will be, this will be a value of 1. And this one will almost always will be a value of 1. This is 1 point. You could do an infinite number of points, so very often the next step is to do a 4 by 4 by a 4 by n. And that's what you're doing when you're playing Call of Duty. So that said, we're going to take you out into Google Docs. So hopefully the calculator, this will all continue capturing. I'm going to go start to my browser here. Google Docs, it should run from your phone, also called Google Drive nowadays. I'm going to go to Google here. You're not seeing everything on the screen. What I'm doing is I'll bring that down if I can. Alright, so I'll try to bring that down. Now this is what you see, or you want to eventually get to a point where you've installed Google Drive. Of course you want to check your email, but you go to Google Drive here. And in this point we're in a workshop. I'll do it outside the workshop. I'm going to create right now a spreadsheet. You can, in fact, works very much the same as Excel, and we all like Excel because that guy went into space and he gets really cool stuff. The guy that invented Excel actually is Martha Stewart's boyfriend. So there's a little bit of trivia for you. He's one of our space tourists. Some really interesting people going up into space. Some of them do great things in terms of education. So I'm going to now show you how to multiply a vector, matrix times a vector, in a spreadsheet. I'm not going to do the little things that we tend to do, which is to make these things more visual. I've got some other videos on that. I'm going to feed in my vector here, my matrix. Remember our matrix was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Once again, pointing out 12, 13, 14, and 15. 14 and 15. That, of course, being 16 items. And if you were going to run these in a list, a straight list structure, position 0 is there, and position 15 is the last one. You could also call these -1, -2, -3. So that is your matrix. Your vector, we said, was 1, 2, 3, and 1. And a vector, if you didn't pick up by now, is just a matrix of one column. So a vector is a series or a list of numbers. When you think about them originally, they are basically covered as 3D points or something like that, or 3D lines, but they can be infinitely long. Kids are playing that. They basically can be thought of as a set of state variables, if you would, and this can be thought of as a transformation. You're now going to apply the transformation to the point and get an answer. You do that by going to a spot here, picking the size of the answer, I think, so you know it's got to be a 4 by 1, and then doing right click, do it again. I'm going to go here, and you put equals in, equals M matrix multiply. Matrix multiply. You open the parentheses, you grab across, or put the addresses of what your matrix is, close, put a comma there, grab what is your vector, close that up, and now you have a data structure that gets you exactly what we did earlier. Okay, so that there is the calculation, and of course we know the great thing about that is we can now all of a sudden, if we want to say, well, really we gotta, I think this works as an inverse. If I make this 30 here, see if that works, I make that 30, this should, I think, get half as big. Let's see if that happens. Oh, I guess that doesn't work. So I'll go back here to 30. It was 15, right? Let's see what happens to our values. 15, that's 65. And if I make it 30, so that doesn't work that way. That's fine. So maybe this scale factor, let's make this 2. And that, let's make it back to 1. All right, so 44, well, we don't know what it does. But generally, playing around and watching how systems respond to perturbations in one number can also be thought of as place value. So just like 1 is 1, but 1 is got some nuance in it, place value also has some nuance in it. So you've done all this. One of the things you definitely want to do if you're playing around with something like this, and we're talking now at about high school level probably, or in the gaming world down below, is to colorize these perhaps. So you can go there and change all their colors maybe to that color, or even the background. We don't know that's going to take up the background you got there, and then colorize this as well. The background might be this, and then of course here you might once again go ahead and change the background to something else. This is A, X equals B, even to the point where you might want to go ahead and change the font. If you're really dealing with the gaming and the application of where this is, real world, I'm not going to call it real world. Yellow, it's red. Green is typically the X, and blue is typically the Y. Check with your gamers; they generally know that. So, and it might vary. I'm trying to get that. Is it working? All right, last one. So I'm doing the background, unfortunately. So the text color. If I make my text color blue, then obviously my background has to be something different. So that kind of sense of how the spreadsheet works. If you want to look at how to do that in Excel, it takes something called a chord. So when you grab the matrix, if you grab your selection there or arrange, you got to go like a shift grab, a shift return, or a shift control. So that's how you multiply a matrix times a vector to get a vector. I'll end up with this. One of the key things about, at least in my estimation, as we're teaching both to what the kids got to get now and these larger core knowledge, transferable knowledge, is the fact that when we do matrix stuff, we don't divide by matrices, we multiply by the inverse. So I'm going to finally show you how to get the inverse of that matrix. It might not take, because it might not be invertible. But if I grab across here, right, and I do now this M inverse, sorry, you got to use an equal first, equal M inverse, right, M inverse, and then I again grab across here and do that. My presumption here, it's not invertible. It's giving you it is not invertible. So this is a non-invertible matrix. You won't talk about what that is, but that's how you go about quote-unquote dividing in matrix algebra. You don't divide, you multiply by the inverse. Go back to here, I'll do the same with the calculator. If you look on the calculator for an inverse of a matrix, you don't find it. It uses the same inverse. So how do I get the inverse of a matrix there? I'm going to go turn it on. I'm going to do this time second matrix. I'm going to take matrix A and I'm going to take its inverse. Hit that and I should get some sort of error. Singular matrix. So whatever that means, there's a whole discussion. Hopefully we'll have some great TED videos, maybe inspired by things that you do, say, or will do or say in your classroom, and go from there. I will now file save this. I'll file rename it, and I'm going to sign off before I do it. We're going to call this class example SPASD. All right, so we didn't do that real time in class, but did come back later. It would be great to be doing it real time in class and connecting. And what I'm going to finally do now is show the share button here, different ways to share. I can all of a sudden actually go out, and I'll stop there, choose from contacts, go to a list, and shows my contacts and share with everyone, I'll do that in class. Thanks for listening.